Together, we lay the foundation of knowledge, build the pillars of innovation, and raise the structure of tomorrow. Wishing everyone a bright and inspiring day ahead. I'm Mubashran, third year civil engineering student.
And I'm Jabba Joseph, second year civil engineering student.
Will be our host for today's panel discussion. As we stand at the crossroads sites on the latest trends, challenges, and career opportunities in this dynamic industry. With this, we wholeheartedly welcome you all to this exciting panel discussion on emerging trends and opportunities in civil engineering under the flagship Nexus 6.0. Before we get into the program, as a mark of respect to our motherland, let us all raise for the Tamil Thai Valthu.
நீராரும் கடலொடுத்த நிலமடந்த கெழிலொழுகும் சீராரும் வதனமென திகழ்பரத கண்டமிதில் தெக்கணமும் அது சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மலங்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிலமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Before we begin the session, I would like to give a brief introduction about our department. The Department of Civil Engineering was established in the year 2007-8 and ME Structural Engineering was started in the year of 2013-14. Since inception, the Department of Civil Engineering has been imparting knowledge in general engineering concepts and studies in civil engineering. With the concurrent acquisition of technical skills and labs, inspiration and awakening of the young minds by vibrant teachers, the students are engaged intellectually in the college. With character, dedication, brilliance, effectiveness, and enthusiasm, they became analytical in their approach and transformed themselves as engineering professionals of the future with ethics. Our alumni are spread across various countries such as Australia, New Zealand, United States, the Middle Eastern countries, and many more. To name one from each country, Mr. Satish Ramar, founder, Strategic SR Management, Dubai. Dr. Hariharan Nahanathan, educator and lead brain associate, Wentworth Institute of Technology, United States. Ashwini Krishnamurthy, graduate structural engineer, Joseph O'Reilly, consulting civil and structural engineer, Ireland. Divya Wainstreet, construction engineering and project management, Canada. Vijay Venkataswamy, graduate structural engineer, Francis Bradshaw Consulting, Stockport, England, UK.
Raghavendra Ganesh, Construction Management and Engineering, South Holland, Netherlands. Arjun Manoharan, Asset Delivery Engineer, Wellington, New Zealand. Ms. Gautami MK, Planning Engineer, Shama Development, LLC, Dubai. Gopi Krishnan, Assistant Manager, Structural Engineer, Solar, Brisbane, Queensland, Australia. And Tamil Kalai Selvan, Construction Manager, Nuclear Project, L&T, India.
The recent placement season has seen our students secure impressive position in various renowned companies. Notably, 2 of our students have been placed at Auditus with a lucrative package of 25 lakhs per annum. Other renowned companies include JDC India Epic Private Limited, Wood India Private Limited, ARS Steel, EVERSENDAI, BlueScope, Alchemica and Ultracon.
Once again, it is my honor to welcome you all to today's program. I extend a warm welcome to our esteemed panelists of this event, Engineer C.Y. Shivaji, Vice President and Head, Special Initiatives, EDRC, BHNDEF IC, L&T Construction, Chennai, Engineer Jayaraman Jayaprakash, General Manager, Civil and Structural Section Head, Technip, Engineer Soundararajan Arumugam, Head Engineering Division, EVERSENDAI, Construction Private Limited, Engineer Shivashankar, Technical Advisor and Civil and Structural K. Officer, General Management Program, ISB, Hyderabad. I once again welcome you all, sir. Leadership is not about titles, positions, or flowcharts. It is about one life influencing other. With this inspiring quote in mind, I am honored to introduce our principal, Dr. P. Devasundari ma'am. Her visionary leadership, unwavering commitment, and dedication to excellence have been the driving force behind our institution's growth and success. Under her guidance, our institution has flourished and we have become a community of learners, thinkers, and achievers. Welcome, ma'am. I also extend a warm welcome to our head of the department, Dr. S. Lavanya Prabha ma'am, who has always supported us and keeping us in position. Her tireless efforts, guidance, and support have been instrumental in shaping our department's growth and success. Welcome, ma'am. And finally, I also welcome the pillars of our department, our faculties who are invariably keeping us strong and upright. And finally, I welcome our future civil engineers.
It's an honor to introduce our distinguished moderator, Engineer Soundararajan sir, a registered chartered engineer and fellow of the Institution of Engineers. Soundararajan sir has demonstrated exceptional expertise in his field. Soundararajan sir has been recognized as one of the 100 influences of steel by steel structures and metal buildings. He has delivered numerous keynote speeches and presented papers in various journals, including the International Journal of Structural Stability and Dynamics. His innovative approach to design has resulted in significant reduction in structural steel consumption. His expertise in value engineering and smart solution. It's my pleasure to invite Engineer Soundararajan sir to the dais, and I also request Principal ma'am to do the honors.
I request Principal ma'am to stay back. It is an honor to introduce next distinguished panelist, Engineer C.Y. Shivaji sir. A highly acclaimed engineering professional, Shivaji sir has over 40 years of experience in structural engineering. He is a fellow of the Indian Association of Structural Engineers and the Institution of Engineers. Sir has demonstrated exceptional expertise in various aspects of structural engineering, including and high-performance concrete. He has received numerous awards and citations, including the prestigious ICI Ultratech Outstanding Concrete Engineer Award 2024. Currently, he serves as the Vice President and Head of EDRC Special Initiatives of Buildings and Factories IC at Larsen & Toubro Limited. It is my pleasure to invite Engineer C.Y. Shivaji sir to the dais. And I request Principal ma'am to do the honors.
Distinguished panelist, Engineer Jayaraman Jayaprakash sir. With over 34 years of experience, Jayaprakash sir is a seasoned professional in civil and structural engineering, project management and Quality management. Jayaprakash sir has worked on numerous high-profile projects, including Revise LNG, Abu Dhabi, and IOCL, Numaligarh Refinery, India. He has also gained international experience working with Technip in France, Abu Dhabi, Italy, and the USA. Currently, he serves as the General Manager at Technip Energies India. It's my pleasure to invite Engineer Jayaprakash sir to the dais.
Panelist Engineer Ravikanth, Chief Technical Officer of the General Management Program at ISB Hyderabad. With his illustrious career spanning over 25 years, he has been a pioneer in driving digital construction engineering solutions globally. His remarkable expertise in structural engineering and digital workflows has enabled him to successfully deliver over 1,000 major projects worldwide. As a key representative of J&F, he has demonstrated exceptional leadership in building client relationships and implementing sustainable business practices. It is my pleasure to invite Ravikanth sir to the dais.
Our distinguished panelists are Shivashankar sir, a chartered engineer and international professional engineer. Shivashankar sir is a member of the Institution of Engineers and has over 25 years of experience in the field of civil and structural engineering. Shivashankar sir has worked with several prestigious organizations including KBR, Mary Technimont, and Dow Corning Corporation. He has expertise in structural engineering, onshore oil and gas structure, and high-rise building. Currently serves as a technical advisor at KBR, leading projects for international clients like Shell, SR Oil, and Total Oil. It's my pleasure to invite Shivashankar sir to the dais.
Sir, thank you.
And BIM, which is Building Information Modeling, which are reshaping opportunities for young professionals. With that, let's begin our discussion. The discussion will be moderated by Engineer Soundararajan sir, and we will have an interactive Q&A session towards the end. We encourage you to actively participate and make the most of this opportunity. I now invite our moderator to lead the session. Sir.
Good morning to everyone. Yeah. So this particular section, I am very grateful to the chairman. Our honorable, highly smiley principal madam and HOD, who is highly active. Even if someone wants to get into a dormant mode, she will never allow that. So she makes everyone active. So and it's all for us. It's all for around. Even the industry and the engineering students. These three persons, whomever I named, they are working for us. It is not only for you, it is for us. It is since if you are getting upgraded, then it is our work will become much easier. So that is how. So today has to be a highly interactive section since we five are representing each and every field of civil engineering. We are there here before to make sure that you get the sufficient exposure towards the latest trends and what is that it is there on your plate, what is that you are going to choose. So whatever it is there, whatever the queries you have, you can raise it upon and you get answered for that. Yeah, to start that one, the first question is going to be to Mr. Shivaji sir. Being the part of L&T and the construction leader, shall we hear from you how the 3D printing along with the AR and VR facility which you have demonstrated in your thing, how things are getting flourished? Can you just explain?
Hi, good morning. Thanks for the opportunity to the ma'ams and the chairman. Glad to be amongst the intellectuals here. First is the topic itself is talking about the emerging trends. So first we should little bit go back why we need a 3D printing and all that. Probably you must be seeing there is always a shortage of skilled workers in something. Civil engineering field, if you really see, it is a intensive physical plus knowledge plus the intellectual things plus smart things are all needed. Gone over the years, if you really see, the entire evolution is based on the civil engineering, starting from the kings and to the world what we are having today. Having said that, there are problems coming up in terms of availability of resources, manpower. Also, there are challenges. Normally, the civil engineers are always challenged by the architects. They come with a kind of greater innovative ideas and stuff like this. So there is always a challenge for the civil engineer to meet the kind of forms, shapes, profiles and other thing. Second is with respect to the time constraint, because today everything we need fast, right? The third aspect is we also need to finish it with respect to good quality, safety and meeting the sustainability standards. So the precast was the one of its kind which is developed long back, maybe more than 70-80 years. In fact, L&T's first one of Mr. A. Ramakrishna is a pioneer in precast constructions. Many of the constructions have been done. So 3D printing is a little bit evolution from the precast, I could say, in terms of the least manpower needed, highest quality, and it all comes with the concept of your toys, right? Whatever we see, the Lego toys, I think probably you may all be very familiar with something like that, and to get the kind of a form, profile and shape. So basically it is nothing but a pumpable concrete. Concrete, you all know, right? You will be studying in third and final year of studies. It has got the different properties. It need to have a flowability, it need to have strength, it need to attain the strength in 7 days so much, 28 days so much. All the codes are all very well defined it. So this 3D printing comes as a solution for the 3-4 issues I said. One in terms of time, second in terms of labor, third in terms of the forms, profile, shape and something like that. Highest qualities, least carbon emission. Today we are all talking about sustainability, right? Come summer or winter, we always say Chennai is going to get flooded. The summer is compared to last year, this is going to be hot. I think this is the story we are keep on hearing. It's all due to the environmental changes because of the CO2 emissions. So this comes as a blessing to the civil engineering team, where you can have different profiles. Today, we have started this exercise around 2017 or 18. We did, in terms of the concrete mixes, we have a very great breakthrough. As you all know, concrete is good in compression but not in tension. So at present, what we are trying to do is maybe a ground plus single story structure or ground plus two story structure. We started doing a small invention. In Kanchipuram, we have a factory. There we did a ground plus one structure first. Then I think I was just talking to the ma'am. Here in neighborhood, within about 200 meters of your campus, we have LTR Avinya, a residential complex of L&T is coming up. The office is made of 3D printing. Now recently we have, we got more popular during one of the post office we did in Bangalore. It was done in about 25-30 days kind of thing, and then Prime Minister tweeted it. Suddenly it became a big thing, famous. Then after that we extended this to Chandigarh, where almost 1 lakh square feet of building. It's a huge building. It's done with precast plus 3D printing. That is the largest office complex done so far in the record. Recently we have done one more building of factories at Chennai. All these technologies, it needs approval, because you have a standard codes and everything, IS 456, it's all well established. But again, we have to get a special approvals from BMTP is there in Delhi, where they encourage the new innovations and stuff like this. We have collaborated with IIT Chennai for some of the aspects. We are exploring now ground plus 7-story structure. The moment I think the idea is that when we say it's all speed, fast and everything, you should reach for the mass. There is no point in doing 1 or 2 small buildings. So our aim is to expand to the maximum horizon where it can, all the party can get benefited. Recently, today morning, Mr. Chairman was telling, there was a demand of 3,000 engineers needed. Once it comes like that, you can have that kind of a technology. You can have the smartest of the engineering, civil engineering team sitting over here. We can collaborate with the MEP and other people, because the 3D printing, if we take one more minute on explaining the 3D printing concept, foundations have to be still in situ, right? In the sense that it will be a normal wall foundation, strip foundation kind of thing. We need to come up to a position where we establish all our mobile platform to move those telescopic wings. Today there are restrictions about 7 by 7 meters is the size of the frames what we do. We have made our own technology in terms of growing higher, in the sense that we can go taller. As I told earlier, this is going to be a concrete, strong in compression but weak in tension. This goes in terms of layer by layer. I think many of you must have watched the films of 3D printing and stuff like this. It is basically, it comes with a double layer concrete running across the design, any shape profile, it with a cavity in between, and that cavity we use it to run our mechanical or electrical or water lines and plumbing, something like that, so that it gets concealed. Then the exposure texture, if you really see, it is nothing but you will see a lot of waviness and something like that. But that's some of the designs. If they want, you can do it. You can paint it, or that itself can be treated as a feature. So it takes only about 20-25 days to build a ground plus 2 storage structure. So the challenge is, in terms of the concrete, when you are doing layer by layer, it should settle. I mean, it should set at the same time. It should not lose its viscosity. It should not become weak or something like that. And then the other challenge is the green concrete. When you do, because you can continuously keep doing it, because after all it is only a machine, not the person. So once you sufficiently, it's about 4-5 layers are built in, the load start applying at the bottommost layer. So that should attain the kind of a strength quicker also. So we have the challenges in terms of flowability, because it is just like a paste, your toothpaste kind of a thing you can imagine. So imagining concrete in such a fine aggregates and I think itself is a very challenging one. It need to flow, it need to have strength, it should not break, it should not collapse, it should maintain its form on its own, maybe self-sustained, it need to there, it should attain strength. So these are the challenges, and that is the USP of the different companies. Many people have tried, many are there are many formulas are there, but the choice of fine aggregates, coarse aggregates, the plasticizers, the setting, this thing, that is the engineering aspect. That is the most challenging for the civil engineers. Probably, I think some of you start practicing, you can become the expert in it. So I think I'm talking, if you give me a chance, I'll keep on talking. You don't stop me at some other point. I hope I've communicated the intent of 3D printing, and that is going to be one of the definite future. Maybe it's a year or 2 years time, we will be breaking the ice in terms of going for high rise with rebar in picture. Then it becomes very competitive environment. Today, in terms of economics, it is not very same equation as our in-situ or precast concrete. It's about 20 to 30% costlier because you have to use the machine equipments and stuff like this. But once you start doing a mass housing, automatically the prices will be most challenging. Thank you.
Just to add on, can you just comprehend on the year and year facility?
Oh, sorry, I missed the most interesting part of it. We all know, right? Today, many of the advertisements you do it. You have in your campus. I was just going through the campus. You have the experience center, right? So today, what is the demand? Everybody's dream is to build a house. I will start with a simple example that everybody wants to build a house. So we go to the architect, he draws in plans. We civil engineers understand the drawings very well. We will be able to understand and feel it. But finally, who is getting the, where you are getting the work done? It is done at the working labor level. How much they can be able to understand the drawing? That is the biggest challenge. Today, the three-dimensional one is one which makes the life more interesting, because what we see is what we are going to execute. So a kind of a 3D imagination is always necessary. And what we do when we take a house, suppose I am the designer, I need to talk to the client. Client is what you are wanting to build the house, then I need to come to you. You may have different concepts, different ideas. Simple house, if you have to do a simple living room, at least there will be 4 in a family, father, mother, son and daughter, or a grandfather, something like that. Do you think all 4 will have the same idea? Yes or no? No. So each one will have a different idea. So you will try to tell in terms of that, I want a blue screen, I want a green color, I want the TV to be here, I want the shelf to be there, I want the crockery unit to be this. So how do you all come and then converge into a one single point solution? So what we do is we develop that in AutoCAD or thing, then we get into the building information model, we get into the 3D Revit model, then we'll be able to convert into a Navis file, and then we start running a kind of an animation. Yes, animation is enough. Probably those days it was okay. Now we have to come into a VR, virtual reality. I've just given an example of housing to start with, but in L&T we do the projects which are mostly complex in nature. In the sense, there are many competitors, many people are all there, but when it comes to a challenging projects, L&T, I all know that whenever you say about L&T, you talk about the big projects because that is where the challenges are there. So I've done 3 big airports, 2 in Delhi and 1 in Hyderabad. So plus Hyderabad Metro we have done. They're all very highly mechanical, electrical, plumbing, system intensive designs. So you all know, you're all seeing the auditorium here, you're seeing the fall ceiling here. Beyond that, what is there? If any of the MEP team is there, they will be telling a lot of stories in terms of air conditioning, the fire lines, the plumbing lines, the light fixtures. They all have to be there. How do we know that they are all coordinated, integrated, so that, and again you all know, if you have to build this auditorium, it's not one man's job, right? Civil engineer can come and do the concrete wall, plastering, masonry, and he can do it. Then the electrical guy come, the plumbing guy will come. If he doesn't know where the routings and everything are there are going to be clashes, right? Services are going to fall with each other. We don't know whether it is properly done or not. Second is the sequence of construction. We all know, suppose you have a toilet above, right? Then there has to be a sanitary sewer line need to run. It need to run can only in a gravity line. So that takes the precedence. So that kind of a slope need to be done first. What may happen is, once you give the contract, some other contractor will come, the electrical contractor will come and do the job and go. The plumbing contractor, you may not get it. He may come after some time and he will say, my line is clashing. How to avoid all this? So we all build this. We do each and every services. You can imagine a kind of a theater, or if you go to a mall, I think everybody you go there, right? If you go to a mall, you just see the ceiling, because most of the malls doesn't have a false ceiling. They are all black painted. You can see the extent of the MEP services. The duct itself will be about 1.5 by 2.5 meters size. So they need to be hanging. There will be a lot of services crisscrossing. How do we know all these things are there in place? So all this we can virtually see in the building information model. Using that building information model, we go to the renting shop and then we get the VR done. With the VR, what we do is, especially now I'm talking a little bit of higher in terms of the airports stuff. When we build an airport or a metro or any industry, if you do it, it is not one-time work, because they have to be operational. So the operations team, that is where they come and then they see, suppose if there is a problem in this particular thing, how do I go and get an access? How do I explain them? So it cannot be done in a 2D drawing. If I show you a 2D drawing with all the service coordinated, what you are seeing is only a rangoli, right? Different lines, different colors, it's going to become a very complex things. But the same thing, if I convert it into a 3D, and then if I take you through a VR, as if that I am walking on a walkway above the false ceiling, whether they have got an access, whether I'll be able to take the machines out for service and other thing. All this with respect to the nut and bolt detail, depending on the BIM, whether we do a LOD 300, LOD 400 or LOD 500 kind of a thing. That much details can be visualized and then it can be projected on screen. So what does this do? One, as a customer, I know before execution, I know what are the things I am getting. That is the first point. Second things, I do talk about the RAMs, reliability, accessibility and maintainability. Whether it is there or not, I totally get convinced. Whether I get the sufficient height, sufficient space, I can try with the different furniture layout, different seating layout. All this can be done virtually. So that is about the VR. Augmented reality is one. Today we all there. Again, you have so many people. When we appoint airport project, there's more than 25 to 30 consultants will be working on the project. Some of them are overseas, some of them are local, some of them are away from Chennai, somebody may be sitting in Bombay, Delhi. How do I talk to all of them? How do I get their kind of inputs on time? So the AR comes in thing. Today we are talking about MR, mixed reality. What is mixed reality? Always know I'm basically a design engineer. I do the drawing on board or design calculations on the PC, something like that. I finish it. But the taste of pudding is in eating. So it need to be demonstrated at site. So how do I do the demonstration? I go to the site. Imagine this only a frame is there. Nothing is done. I use the mixed reality. I project all these things. I draw lines. I know I'm mixing the real world. I am also taking the virtual world. I do mixing. I know where the lines need to be drawn. I can mark up doing things. I can say that this corridor is clear, this portion is clear. So we have done in proton therapy, that project in OMR, Apollo, we successfully got implemented, and it's a default in any of the L&T big projects. We do BIM, Building Information Modeling, AR, VR and MR is a default. It helps a lot. It gives the kind of a communication what we want to communicate to all the people. Problems are less, rework is less, engineering time is saved, lot of waste is saved. When we talk about sustainability, it is not only conserving, it is also minimizing the engineering waste, lean construction. So AR, VR has got a tremendous potential, and then it is again, it comes with the IT background with respect to the civil engineering, architecture, MEP and stuff like that. So one of the suggestion is that the scope for civil engineering is enormous. This is one of the aspects probably the young engineers you like to pursue, you can pursue. It is a bright future is there for this process of AR, VR and MR. Thank you.
Thanks, sir. Thanks for taking us even visually what you have experienced by talking about AR and VR. We also traveled with you. Thank you, sir. Mr. Jayaprakash, sir, you have been there in the industry for a very long decades. 3 or 4 decades you have been there. Can you just explain how the materials have been advanced when compared to the earlier stage when you started your career, and currently what are the recent materials, trends, how you have been doing it? Can you just explain that?
Friends. So you are really very fortunate to have a good management and good departments and good principal to have a lot of experienced people to call and give or sharing your experience. We are also very honored to be here to share our experience with a lot of projects we handled. So when it comes to the civil engineering, people feel always it is concrete and brick. Maybe 30 years back, 40 years back, it is concrete brick, conventional foundation, normal open foundation, bricks and all. That has been in the 90s, 60s, 70s, okay. So now slowly it has moved towards this called, there are 3 types of construction I could say. Normally the stick built. Stick built means everything is brought to site and constructed at site. It is stick built. People are all materials like steel, bricks, everything to brought at site and construction at site. That has been before 30 years. Then slowly it has moved towards partially modular thing. What is partially modular means? That is fabricated from concrete, is evolved to steel. So now you can see most of the buildings are coming in steel because advantage is very fast, very quick, sometimes very economical, and now steel also available plenty. So most of the buildings now, including the malls, even highways, now we go to highways, lot of new buildings are coming in. Now almost we cannot see any concrete buildings or brick buildings at all. So that's why our steel expert could say more on this. What is the advantage of steel? So now there is second part is coming to partially stick built, partially modular. It means it's steel and combination of steel, concrete, and with all the plasters, backwards, everything. Now the trends become this century after 2020. It is moved entirely different. Now the concept is modular. What is modular structure? So it is not at site, everything at yard, consider everything at yard, including all the bricks, foundation, including foundation also now it's possible. Consider everything at yard, somewhere very near, very far. Let us assume I am in the oil and gas industries. We have a lot of pipe rack structures, modular structures, plant structures. Everything, suppose if you remember, no, if you have to do everything at site, it takes long time, maybe years, 12 months, 15 months. But every client want to complete the project in very short time, commission and get the profit. So what we do as a civil engineers, now we are moving from conventional to semi-conventional and become modular. So we can have a yard at somewhere 50 kilometers, 100 kilometers. Even some of our projects are modularized in China and Korea, including the mechanical equipment, piping, electrical, plumbing, everything all together, construct at somewhere the outside yard and bring through ships up to the shipyard, then move towards land transport, then lift as a full module and erect at site. Only thing what we need to do is ensure the foundation alone construct at site. Then all the modular, including everything, just lift and place it. So this is very much cost effective in terms of 30 to 40% cost effective, and schedule is, we can crash a schedule. That is why as civil engineers know, we have to think differently. Okay, maybe you should come out of our box. We have a lot of opportunities in this modular construction, and also it's very interesting because as a civil engineers and structural engineers know, it is very interesting to be a part of this modular structure, and we can go to yard, we can see how it is executed at yard, then we can also witness how it has been moved through ships, and we can also witness how it is moved through land transported and lifted. So all these analysis, no, there is different type of analysis to be done for different concept. Now most of us in colleges, we just know only STAD or manual spreadsheets, but these are very special nature of analysis design. It is very much interesting, and also know it gives keep learning the new techniques and all. So there is lot of opportunities and scope for all of young engineers to go into next level of modular structures and learn ourselves. We can update ourselves with various new techniques. So it's very much interesting. Every day, no, technology is evolving. As already still this view through softwares, we can go through all this in class and class management. Everything we can do in 3D and assemble at somewhere yard, bring to site. This is having a huge scope, and definitely I recommend all our young engineers to learn something on this. What is the thing we can go to net? There is lot of knowledge is available in the net, and also what is the different type of land transport, sea transport, lifting analysis. So this gives a lot of ideas about the where we are going towards next step. So there is a lot of emerging trends, technologies there. Definitely, this will be a good scope for our civil team and structural team, not like a conventional. So when you go to high-end, we got a lot of remunerations there. We have good pay, good technologies, innovation. We are directly involved in all these concepts to commissioning and erection at site. So this gives a good understanding of and knowledge we can really share. When it comes to the end, finally, we will be very happy to see the structures erected at site with a very short time and with economical. So lot of studies we can do it. So definitely, this is going to be a future. Modular structure is going to be a future trends, and definitely there is lot of scope for our civil engineers in the future.
Thank you, sir.
Hear over the decades how you have evolved with the construction industry. Thank you a lot, sir. Next question, Mr. Shiva. Yeah, I always love people who came from not from BE. We start with diploma, we start with the AMIE. So I really personally affiliated towards you, since I really feel that when compared to BE, diploma is the better for any engineering. That is my personal feeling. Where instead of studying complex things. In diploma, we study the basics first, basics only, basics perfect, then we get into the next one. Okay, fine. Now can you tell me what are the latest software solutions and solution techniques, since normally KBR always we talk about sustainability and all. Can you just touch about the technological solutions, softwares, and how far KBR is putting towards the sustainability?
Good morning all, good morning students, good morning Madam, Principal Madam and HOD. I thank you for this opportunity. We are all grateful to this college because the college is arranging a appreciation like this to have knowledge on what is the emerging trends in the industries. Really it's appreciable to the management. We are always thankful to the management. In regard to the questions, what sir said, what are the softwares used in the latest now? Because see now there are civil is a vast subject, and what kind of field you are going to enter, that is a decision you are taking in after the 4th year, which kind of industry you want to take into that. Some have skills in structural engineering, some have skills in project management. If you want to involve in designing something, you want to take softwares like S3D, E3D. Nowadays, no, there is no draftsman, other things and all, no discretion in MNC and all. Whatever you perform, if you perform well, you will be paid more than the structural engineers. Some designers are paid more than the structural engineers. That is happening. I'm really telling you the truth. See, there are softwares now. What we are using the software that directly I'm telling you what is S3D, the software that is called olden days called PDMS. Process design software, it was there. Now it is changed to S3D, E3D, developed by Aviva. That is the model. As first Shivaji said, you see the entire plant, including if you are, I'm designing a pipe rack, that entire pipe will come in that, steel structure will come that, whatever equipment coming on that pipe, everything, even HVAC, electrical cables, all will be modeled in that. You can see visually what is happening, is the clash is not or not. You can see that. For it requires lot of, olden days, oil and gas plants are considered 5 years, 60 months IOS conducted. Nowadays they put it in 2 years. They want to implement the plant in 2 years. That's what modelization came now. We do the plant, we'll finish the design, modelization will take place in some other country in China, it's shipped, and it, as I said, sea transportation, land transportation will do, and it's a costly item. It is nowadays affordable only for oil and gas industries. Now its trending is moving towards other industries if it's feasible. The 3 main reasons for modelization is labor. Some areas in Australia and North and Western Australia, there is no people at all. Only land is there. But ore was there, petrol was there. So there no people will work there. So you have to do modelization only. Some countries in UK, that is very costly. Their modelization will to be implemented. Whether it's cost or not, no other option. You have to do modelization only. Offshore structures, you can't go and construct in the center of the sea. So you need to modelization. You have to put in the plant in the shore. L&T is doing in Kattupalli, and they'll put it in the middle of the sea. Very complex projects, they do use it in that. Coming to KBR project, we are using a STAT for analysis, structural analysis, and other some SAP also we are using. For design aspect, we are using E3D, S3D. These are Aviva product. And Tekla is one of the most prominent software for steel industries that everywhere we are using in both oil and gas as well as in the other industries, housing industry also. And if you see Tech, Autodesk, AutoCAD, you should know. I think colleges are teaching us everything. You should know basic AutoCAD, everything. In my suggestion, you should know Excel very well. All the commands of Excel you should know. Whatever the software you do, ultimately you learn in Excel only. Nowadays, AI is telling all the formulas, everything. Even not telling, you can learn it on your so that you will have grip. All the output of all the softwares will ultimately put in Excel. Then we filter it, data filtering it. Some students are doing it. We recruited a lot of graduates from your college as well as from other colleges. Students are performing very well. How much you put in interest, that is the main matters. Don't waste time. Keep on learning. Learning is limitless. I started my, as I said, I finished my diploma in '92. Then I continuously studying, working itself. Then I finished my AMI. Then I finished my ME with Gates Scholarship. So that is you have to learn, keep on learning. There is no stop for learning. There is no age limit. Everybody has to learn continuously. Any further questions you can ask me so that I can tell you. These are the softwares used in oil and gas industries. For project management, for some other skills, they doesn't want to analysis and other things. They are very skillful in project management. They can learn Primavera, some other softwares like in MS project management softwares. All those things. You can coordinate all the teams, mechanical, electrical, civil, process, and you engage in project management team, so that there will be a coordination. Otherwise, the project will not be successful. Ultimately, civil engineering is a department it's a basic discipline to serve the society. Vast from metro, roads, railways, drainage, treatment plant, buildings, hospital, everything is civil engineering. There are a lot of opportunities, but how you project yourself, that is the main matters. Thank you.
Thank you. Next question is to Mr. Ravikanth, a man of great vocabulary, and we have been there nearby 3 kilometers away, but for the past 3 months I have been seeing him very often. It's sometimes when you are residing nearby, but you never see, but somehow after some time you see him daily. So he's a great friend of mine, and the question to you, Mr. Ravi, is there are 2 magical words currently people talk about. One is AI and another one is BIM. I feel that you have already expertise that. Can you just throw some light on that?
Fantastic, yeah. Thank you very much. Good morning, good afternoon, I would say. Yeah, we're just clocking there. Thank you very much for the opportunity, madam. Yeah, principal, madam, and HOD. I think I met HOD in the last university, kind of a little bit of a session there. Then she said, like, okay, there is a kind of a bit of a panel discussion. Is it something which you can highlight the kind of students? Yeah. Yeah. I would like to ask one question, yeah. I think it was kind of a great insights from the panelist, from the every industry. I think you got a kind of a bit of a context set for you, being a kind of a engineer, getting onto the kind of a practice engineer, yeah. I think that's what I look at when I graduated. According to you, a question to you, what is the latest modern invention in the world? Very simple. Which has changed our lives, which is changing our lives. One word. AI. Before that, okay. AI is a kind of a technology, yeah? Okay. But what is that kind of a something? It has changed the world, yeah? Very simple, yeah? We all spoke about communications. That is a change maker, yeah? If you say 2000, before, after that, a big change happened in our lives is the communication. If whatever the kind of a subject, whatever the technology, or whatever the kind of an application, platform we are talking, is the communication. How we communicate within ourselves to the world is a big change maker. This is my perspective. I thought of maybe highlighting. Yeah, having mentioned about a kind of a civil engineer, I was also part of you maybe 25 years ago when I was graduated and tried my masters, and I've done my structure. That's a favorite for everyone. Along with that, I have done geotechnical also, because that is something which is, I like it, yeah. Every structure has to sit on the mother world, yeah. We need to know the kind of the stability of it. You need to have the feel of it. So geotechnical is my favorite. Recently I have undergone a kind of a bit of a management program also at a very, very high level to see that, to improve a kind of communications to the world again. That's why I started. Having mentioned the traditional way of doing things, we've been doing it. Possibly you may not be knowing it also, as we all have partly given a bit of a highlights on it. But what is something which is we have to do, as sir was mentioning, is most smart way and quicker way. And what is something which has not changed over a period of time? Somebody would like to take this answer. What is something which is not changed? Time. Very simple. 24 hours time. Earlier we know, still it is the same, yeah? Right? Very simple. Yeah? And time is a common resource to the world, all to the planet. Of course, we are living in a different, to be more clearer, I would say, we are in a different time zones. Maybe the western part is 10 hours, 11 hours ahead or behind if you look at, and the eastern part maybe a few hours here and there. But otherwise the time is something which is constant. But what is happening is, you see, the times we had our grandparents or ancestors, they had plenty of time, yeah? We used to talk, we used to communicate, we used to have stories. But now, time is become very, very precious. It's the same thing, 24 hours I'm talking to you. Earlier the days, now also the same, but the time is become very crucial. As I was mentioning about, time is something which is a resource which need to be utilized for the projects to be delivered. In this one, I was just thinking about one particular example to quote. When Kanchipuram temples were constructed, everybody might have visited Kanchipuram, yeah, the temples. My goodness, get to the insides of it. Entire material is, let's say, a stone material has got a high stiffness in an engineering language. It could stand, but no calculations. Of course, there are Vedic calculations that what are here. But look at the kind of a perfection was achieved here. No technology was there, no paper documentations, but still we could achieve. Only thing is how they have achieved is, I'm not sure, maybe we need to dig out the kind of a Google and get this part, but it's quite interesting. So what has changed from there now? They didn't have a time schedule, yeah? So people, labor, constructed at their will and pleasure. That is my inference. But now what is? There is a time schedule. Contractually, you need to deliver this project or whatever the kind of a contractual obligation, there is a time frame. It has made us a kind of a high disruption within our minds. How we can deliver the same Kanchipuram now within, let's say, maybe 2 years? Can it be done? Yes, it can be done. So that's what the kind of a technology is coming in. What we talk is a building information modeling, or maybe we have coined a kind of a word, AEC. I will add O to it. Architectural engineering, construction, operations as well. That's what I take. Because once we deliver, we need to also operate it successfully. We'll talk about the digital twins and stuff like that. So, having coined this word AEC, as buildings are a kind of a common for a civil engineer. First thing, I was just few minutes before also I was emphasizing on it. The first thing a civil engineer will know is a building. His confinement is towards the building. I think all are 4th year, 5 year semester?
Not all, sir. All are from 1st year to 5th year.
Oh, fantastic. Oh, okay. You might have started your journey with the strength of materials. Students, that is the base of everything. Civil or mechanical, yeah? Right? And as we move around, you are studying structural different advancement subjects and geotechnical, surveying, transportation, environmental, and a few other things, water resources, irrigation, stuff and all. So you have possibly undergone a kind of a whole civil engineering subjects, but still your mind is confined to building alone. Reason? Everybody talks civil engineering is a building. That may not be, yeah? Have a bit of a deeper insight of it. When you travel on the roads, highways, bridges, tunnels, irrigation structures, dams, my goodness. You go around, you see this whole civil engineering assets are built on the ground. I think this is what is a civil engineering. But the key, one particular thing is that awareness or the perception is missing. Maybe you're not getting connected to it. If you connect to it, you will have an awareness. I think that's what we are trying to say. When you learn a subject, I think Madam was mentioning about, you have a great opportunity to go around the kind of construction sites. I think that is what you need to get connected, the subject and the reality. So getting back to the kind of a technology, what I was talking is architectural, engineering, construction, operations, along with the kind of the tradition, theoretical fundamentals, what we are learning, more important is that technology need to be embedded with. I think that is what I'm now taking your subject towards. Why technology is important? Because of the time I spoken about. Because of the time pressure, I need this. You spoken about a kind of AI description. This is all technologies keeps coming in. Okay, we need to embed, we need to use it. One particular perception from my side, yeah? All these technologies, applications, platforms, who has done it? We have done it. Humans have done. Robots are not done, or something is not falling from the sky. It's all we have done. So when we do it very, very easy. Correct? We make it more customer friendly, right? We make it so convenient so that a user can adopt. Here I need to quote one example which was ringing in my mind. Who is the father of C language? Sorry, I'm asking questions, yeah? But it's a bit good insight. That's my perception, yeah? I asked the question to myself. Canigan Ritchie is the father of C. He built his C compiler for testing a kind of a laboratory kind of a program. Yeah? For his own kids, he has built his program. But he doesn't know like a C language can create such a disruption. So what I'm trying to say is, certain things are formulated for certain cases, but the application is we need to decide, right? When you talk about AI disruption, when you talk about a kind of a platforms applications, is we need to decide. So the people who are created, you can disrupt from your angle. So what makes you to disrupt? Your fundamentals. Again, coming back to fundamentals, I was talking a lot on the fundamentals. Students, fundamentals are the basic perspectives. The way you think may be different from your friend. This is my personal example. I still go back to the basic graduation and post-graduation. I study this one, yeah, because when I study now, my perception is different. That's a kind of a big thing, a big learning from my side is unlearn, relearn. Right? Whatever you are learning, you unlearn, make it neutral, and relearn again. So your perspective will change. So what I'm trying to say here, yeah, I'm giving a lot of quotes, examples, stuff and all. The reason is technology is something which we have done. Okay, we are talking about a BIM, a kind of a process, people, technology and policy. The few ingredients which are available. But technology is, somebody has developed, okay, we have Autodesk. We use plenty of Autodesk products. You heard about Revit is the quite prominent parametric objects it can create, and it's easy to learn. We have Civil 3D, we have Naviswork, likewise we have infra, we have, now we are talking about a kind of a Forma, build the kind of models on ground exactly on the Google Earth. So these are all kind of a technology which is making very easy. Suppose if I'm building my particular a kind of a digital model on Earth, I can do a real time a digital virtual model. So this is what is a kind of a technology accessibility is there. How you think is something which you can perform. Likewise, there are plenty of applications. Bentley has got a kind of a plenty of applications. EcoSim, MX Roads. Why I'm saying these products? Question you may raise, hey gentlemen, whether I have to learn all these languages, applications, platforms? Maybe a question may be ringing in your mind, yeah? We are talking so many applications, right? You already studied around 25 to 30 subjects and over which we are embedding 40 plus applications to you. So that's why question raises, what I have to do? What I am supposed to do? I can answer, I can help you. It is the interest. Where you have the interest, sir was mentioning about. Where interest, because each person is very unique. I see each person is very unique. Your thought process, your thinking process, the way you deliver is completely different from your friends. So please try to make out what is that you want to make, yeah? That's my first question to my people, saying that what is that something you want to do in life? Ask this question. What problems or what issues of the world you want to solve? You want to contribute. Please ask this question. Then you will have an answers. Which is a subject line you need to focus with. Keep that fundamentals. Applications are plenty. I can give 40 different applications now. Autodesk is there, Bentley is there, Nemicheck is there, Trimble is there. Plenty of applications which I do not know. May be available. Somebody is building up. AI is also building up a lot of applications. It's making life easy. But one particular thing, whichever the application you use, validation you have to do. People say, okay, I have given a lot of inputs to my application, but who has to validate? The inputs you have given is set right. Is the behavior of the application is right? Or the output is matching my requirement? You have to decide. An engineer has to decide. Say is a civil, mechanical, electronics or electrical, you need to decide. Your basics will count. And you can challenge that output which is produced by the application. Application doesn't mean that it is all right, yeah? Maybe 20% error is there. Who has to rectify? We need to rectify it. How you will rectify? Because your basics are very strong. You can challenge the output. That is what you need to do with. So having mentioned the applications or the kind of a platforms, you please choose from your side. There are plenty which is available. What we do from here is J&F. We've been doing a kind of a traditional services to the construction market, but we evolved as a kind of a technological partner. We have the kind of a heavily investing into the kind of a AI project management, quality management. We provide all the kind of a digital constructible solutions in our office. We have 400 plus qualified engineers who do, and we've been doing it for 25 years on the planet. What sir was mentioning about is on the construction side. But what we do is everything on the kind of a digital virtual models. And we say these digital virtual models are the constructible. What is constructible? Somebody can mention about? Which you can construct, simple, no worries. But more important is, there are two aspects I want to add over here, yeah? Permanent structure, temporary things. You need to have that awareness. Structures cannot be built just like this, yeah? You need to have some temporary supports. In India, I think temporary supports, the health and safety aspects is quite questionable, I would say, yeah? Sir can explain that. But we are focusing much on this. There should be a kind of an accident-free construction sites. So everything which need to be erected, the permanent structure, you need to have a temporary structure also. So you need to also do that modeling, and that constructability also you need to look into. Whether it can be erected, especially on the structural steel, if I say, all the elements which we say is a kind of a bridges, whatever is the thing, it need to be in a constructible form. So with this note, I would say, yes, we are quite active into the kind of a things, and you have a kind of a great future in AEC industry. And I will not, maybe if it is something is there, I'll talk about. O is nothing but operations. Yeah? Once you construct this facility, is it something digitally you can operate from? Remote location. So simple, yeah. You will fix all the IoTs to the device. If any kind of a downtime happens, somebody who is sitting in Canada or maybe US, he can rectify this with the right component which is available, and he will come and improve the kind of a performance of it. That's an operations part of it. So you have a kind of a great future. If at all you look at a kind of the buildings, infrastructure, whatever is talk about kind of the ports, airports, bridges, tunnels, stuff and all, you have a kind of a great example to set from your side. Is only thing is your interest. That is the basis of your career path. Thank you.
Thanks, Ravi. So, Ravi have highlighted one important point, since nowadays we get into software solutions. But software solutions, unless you know the basics, you cannot judge whether the software is providing the proper result or not. So that is more important. Whatever you do, tomorrow you step into a company, you are given with software and you perform an analysis and you think that you are a structural engineer means, no, not that one. You have to validate. Exactly, he mentioned the point. You have to validate. Once you validate that one, then you are a structural engineer. Then you can go ahead in utilizing that tool. Thank you. Thanks for your quick words. Now maybe we can open questions to the students.
So much, sir. The students can ask questions and can engage with the panelists now.
I'm Kopika and I'm studying second year civil engineering right now. So my question is, how do you see the role of artificial intelligence and machine learning evolving in the field of civil engineering?
Yeah, it's a great question, I would say. However, sir was asking to emphasize on that, but I didn't touch the topic deliberately. I thought of maybe you guys are maybe a kind of a Zen Alpha, Zen Z guys, yeah? That's what I can. You are the science evolutionist area, according to me. Yeah, your brains are, the DNA of your brains is wide in a different direction. You are the future of 2040, 2050. That's what I look at, yeah? That's why your question raised is AI and kind of a disruption, which is machine learning, AI, ML, what we talk, or AI, ML, and I say DL also, deep learning. I think these are the kind of topics which you encounter. These are all the kind of disruptive technologies is going to disrupt all the kind of sectors. Definitely, right? Possibly doesn't mean that you have to learn AI. No, may not be. That's why again the question raising is, what is your interest? What problems you want to solve? You want to get involved in the AI? Yes, you can definitely learn and adopt and look for a kind of a application to the kind of a civil engineering. That is one part. You have a kind of a programs, learn from your side and apply into the kind of an engineering part. That is fine. But one side is your fundamentals. Your fundamentals is you're all civil engineers. You have done 4 years, or maybe subsequently you may do 2 years of your masters, or you may get into a kind of a PhD. All the kind of a IT or maybe information technology or these things, platforms that are coming, you need to adopt, utilize into your things. Certainly you need to be aware. I'll give one example. The kind of, you learned about a kind of estimating and costing, yeah? Estimating and costing, one subject is there, right? Yeah. So what do you do there? You try to identify the measurements of the items, let's say civil, structural, architectural, all the kind of disciplines, yeah, by multiplying LBH. That is what you do it, yeah. But there what I see is a kind of a AI technology is erupting, where you put a kind of a my 2D drawing, I get the quantities out of it. So simple. So AI is definitely will make life easy, but that's what I was emphasizing on. Who will evaluate these quantities? I cannot say, hey, AI has given this particular quantities, this is correct. People say, yes, there is something rubbish there, something which is not considered. Because reason, as sir was mentioning about, the things are becoming very, very complex. If a complexity comes into the picture, somebody has to evaluate, assess, validate these things. So again, I'm coming back to your basics part, yeah, the fundamentals. Whatever the kind of AI technologies are coming, please adopt. Please be very open. I am sure you will be open to that because you want the things to be done very quicker, yeah. That's what your generation is. It is needed. You need to adopt to it, yeah, and get into your workflows. And that's what we are also doing with majority. I think here I'll give one particular example. I was also quoting in other forums also, where we are producing the models which are no more redundant. Means I'll create a model. The entire model is monitored or maybe controlled by a kind of a scripting. It's again a kind of AI disruption I am doing with. What I do is, as sir was mentioning about, all the kind of a technology is linked to kind of an Excel or a scripts part. I change the script, the sizes will change, right? So that is what is the kind of a technology already evolving. It has reached. Why reason is, again, because we need to deliver in a limited amount of time. So that makes sense. Is AI disruptions and your a kind of a ML programming and your deep learning is quite evident. If you are able to learn, adopt into that kind of a into your workflows, it will be fantastic. Hope I have answered your question. Yeah?
Yes, sir. Yes, sir. Thank you.
Maybe I'll just like to add few more things. You just imagine, right? You are getting a project where how we are adopting AI in L&T. I'll just give an outlook. The moment first a big project comes, the tender document comes. And you have to quote in say 10 days, 15 days or 20 days. It's a multi-complex project. Every tender document comes with the general spec, technical specifications, drawings. It may be about 1,500 to 2,000 pages of document. Maybe 30 to 40 people need to work. There are hidden conditions. There may be specifications which may be contradictory and other thing. So I'm going to tell there are long-term benefits, there are low-lying fruits. So first thing is using the AI technology, we can scan the document, get into very perfectly organized in terms of product-wise, class-wise, tender-wise, ask it to compare and then give a kind of contradictory inputs, and then we can seek a clarifications. That is at the first preliminary stage. Second thing, I need to get a quote, right? Whenever, suppose imagining that I need to build this Easwari Engineering College once again, there are about 20 buildings, 30 structures, so much of MEP and other thing. I need to group it. I need to say air conditioning if I have to do, whether I need 500 tons of AC, 1000 tons of AC. I'm just telling us in one example. If I have to do it, again I can get this thing sorted out in no time with the perfect specifications. I can send to Voltas, I can send to any other agency, ask them to give a quote with the perfect detail. Before that I can also check is there any contradictory kind of thing. So I can get an immediate quote. Then AI, we are all talking, it's just not the simple thing. It is based on the data, right? Whatever how much ever of data you have, that much the ML or something like that can improve, and then it can say that predictive future can come in. So you need to have first large number of data should be there, which need to be cleaned, which need to be sanitized, and then the useful data need to be available. So before, when I'm coding a college tender, I should have coded at least some 10, 20 or 30 kind of data should be made available. Then using that particular base, using the AI intelligence software, the platform, I can compare with respect to what are the projects which I've coded earlier, what is that I'm doing now. I can make a kind of predictive projection and say, yes, this is what my code is going to be right. Then I do the job. So this is the first stage of thing. Then comes the engineering aspect. Where do I use the engineering? AI in engineering. Same way, I have done multiple hospitals, I have done multiple universities, I have done multiple buildings of that sort. I have the data. So if it is ground plus 7 stories, seismic zone 4 or seismic zone 5, it's a frame structure, shell structure. You name it at different conditions. I've got what is called as a techno-economic indices. So I know if I have to do a 2 lakh square foot of building, what will be my concrete volume, what will be my shuttering, what will be my kg per square meter. If I have to do a steel structure, I know depending on the spans and everything. So the data is very, very essential. That is where the real life engineering comes in. So using that particular thing, I can do the engineering, I can take up the backup work and I can do. Now I have to automate my engineering design. So what again I do, for example, I have to do a sewage treatment plant. I have got the data for 5 MLD, 10 MLD, 20 MLD, blah, blah, blah. I have got this particular data. And I need to do the planning. I need to do optimize space. So I need to write the kind of an algorithm to see that what is the best fit for that particular profile. Once I have that base, the preliminary dimension comes in. Then I get it into this, directly get into the building information model, the BIM. So I write all this, in the sense our team does the APIs and something like that. So this data getting converted into a real-time input into the building information model. What the building information model does, it develops the entire geometry in no time. Once it is done, this has got an interface with either STAD or ETABS or other part of it. One end we start doing the structural engineering design. Other end, similarly, in-house we have developed a lot of design automation softwares whereby I can arrive at the capacity of the chillers, capacity of the electrical routing, capacity of transformers, all that can be done. And to a large extent, I am trying to automate the design. So it gets connected at different points and then get integrated. And finally, I just do the printout of the drawing. It comes as a form of the drawing with engineering drawing. And again, this can be done for repetitive structures. For example, we have a wet, we call it water effluent treatment department is there. The project comes as like a city development. In the sense, suddenly they say give a place near Trichy and then do the entire water treatment plant for the entire unit. I may have to build about 200 tanks, 300, thousands of kilometers of piping. What I do, again I go into the survey and all, I am not coming. Based on the terrain layout, I can optimize my layout, where the cut and fill and nothing is coming. Already, as I said, the 3D civil software is there. So the process of integrating all these things, applying the data and trying to get the advantage is where the civil engineering is going. So once I prepare the design, I give it to my procurement team. Procurement team, based on their database, they know, in the sense, for example, if I have to procure concrete, I have the data, thousands of data available near Chennai, near Madurai. Suppose if I have to do a project somewhere in a remote area of, say, Tamil Nadu. Based on the database, I know where I can source the concrete or reinforcement or any material. Like sir talked about the materials, there are thousands and thousands of materials in the civil engineering requirements. All that, again, it needs a database. I can extract all this particular information in no time. Then I can get the best price. Then it comes to execution part. Once you are at site, how I use the AI part. Every site first is the safety. So high-rise structures, when you have to do, we have got the platforms developed with respect to AI. We identify the pockets where and all the safety requirements are there, where are the heights, where are the openings, where we need to close it. We have got our own AI-based development. It's all, something is going on, something is in long term, short term. We have the ready-made answers. Then second thing, to educate the people. How do we do it? So the entire process is again demonstrated through a virtual model. Means as a safety engineer, gone are the days you come and demonstrate. They can come virtual experience like 3D, 5D kind of thing. You wear the glasses, you sit in this chair, and then you feel if you're falling, you will feel that in the sense like what you call I'm not getting the exact word, simulation. The real-time simulations are all happening with AR VR glasses. You do so you understand the importance of the safety, then the quality aspects, then the constructional aspects. Construction anyway we talked about 3D printing, precast or something. They're all coming into picture. Then the last stage is the digital twin model, where you take in terms of the operations from the maintenance and operation and maintenance point of view. We give them the complete 3D model with all the asset management inputs and stuff like this, with all the IoT of things and something. As I said, you can do the monitoring. What I am trying to give a glimpse is, you asked a question related to where the AI in civil engineering, everywhere it is there. Starting from the tender to design to procurement to construction to post-operative things, and with using all these things again a kind of repetitive projects and something like that. It's all. It is something like it is like a god kind of thing. No, it is omnipresent. It is there everywhere. It is up to us to see where you have the kind of a talent. Somewhere people may be interested in planning, somebody interested in safety, somebody may be interested in quality, somebody may be really facing the challenge of doing work at heights, somebody may be having the engineering skill, somebody have a very good negotiation skills, they can get into the procurement in terms of dealing with the people, getting the agencies, something like that. Then there are specialized materials, expand and joint, waterproofing, chemicals, painting, enormous. Everywhere AI is there. So the point is, don't worry about AI too much. As we all trying to emphasize, is all the fundamentals is what one need to take it. Whatever study duration you are doing here, get the maximum out of it. Spend your time in learning as much as you can. Parallelly, evening times you do either STAD or ETABS or BIM or whichever field you like. It may not be it may not give you that spontaneous results, but within 2 to 3 years time you can find which area you are all inclined, and then you can go in for a specialization, stuff like this. I thought maybe I'll just expand what Sir has told, very specific to the civil engineering aspects. I hope I've done the briefing sufficient enough for you to understand where the AI is there. AI is again, it is something like, it is only a tool. Okay, but main thing is our core engineering knowledge. Unless we know what it is, what AI gives us, output, you only have to validate it. We cannot blame the AI, otherwise it's garbage in and garbage out. But having said that, if you have data and if you, based on the past and I think you can do, you have a fantastic future with respect to AI. Thank you.
Good afternoon, my fellow panelists and one and a half present here. Myself, Sudesh Mitran, and I'm pursuing my post-graduation on structural engineering. As of now, we can see a lot of construction involving sustainable management, right. So my question is that, what are some greater innovations in the department of sustainability that you guys believe which will become the mainstream in the next 10 years or so?
See, now the entire world is moving towards sustainable and green energy. Now the latest trend is green energy, not only sustainable, but you see more green energy and less CO2 emissions, carbon emissions. So now you see all our products, building products also, we are not conventional to different type of material we are searching for this. Where not only the final product is one thing, but from where these products are manufactured. So we have to go from the fundamental. Okay, where is manufactured? What is the material? How it is being brought to site? So we have to start from the beginning up to the construction stages. So now there is now every project, even clients are asking what is the CO2 emission we can reduce it. So when you go for tenders, they don't, not only they just evaluation based on the cost. They will ask, clients are very smart, and even the governments are emphasizing we need to go towards the sustainable products and less emission. So we have a government is having a target. So Government of India has signed up agreement in 2030 we have to achieve this particular requirement. So every company has have some targets and we need to achieve towards that one. So we are trying to see different materials. where is available. Okay, how to use it, complexity, how to make less CO2 emission products. So every company is having one department, or even within department, we have targets. How I am able to achieve this particular target in our own civil engineering. So we have to prove at the end of the project, okay, this much carbon emission I saved. So that's why even if we go to the oil and gases, now we are going towards solar and more towards this CO2 observation towers, and reducing towards the hydrogen, green hydrogen and blue hydrogen. So now all these clients are going towards this sustainable products as well as green energy. So when it is not a magic word, so it is very simple. We have to start from the basics. We have different ideas available, how to make it more sustainable in future also. So now we got this, what is conventional energy systems, normally from coal. Now we are moving towards wind energy. So why we are going towards wind energy? Because it is almost, we can say, zero carbon less. So now from conventional to thermal, and when we are moving towards solar also still not 0%, but almost wind energy is, you can see, 0% carbon emission control. So we have different techniques are there. So don't afraid of, okay, something different. It is very easy, it's very quick. So we can learn everything. That's why now, even curriculum now they're adding one part, sustainable materials, how to use it. So now we are having different building materials, different construction methods, not only sustainable from product, even construction method also we can go for different type of construction methods. So with all the combination of all these techniques now we can move towards the sustainable and green energy and zero emission. That's what things we are doing. So L&T is having lot of products, lot of innovation they are doing from L&T towards the sustainable futures. So now every company is having a target. So that moving towards the target is our aim. So maybe L&T having lot of ideas on the sustainable elements.
Sorry, I'm barging in, but the ideas, don't mind. We are IGBC, green building, leads, we are in the peak. Now the next concept is net zero. Net zero means finally there is no, you don't, whatever you take, you give it back. There is nothing residue is left. Net zero, we are talking about net zero water, net zero energy, net zero waste, and net zero carbon. That is the final thing. What basically it is if you are using a water, you don't draw water from here, but if you are drawing water, you need to put it back. So energy conservation comes in terms of the treated waters, right? Whatever the water you take, you treat it and then give it back to the mother earth. Or you create an artificial pond or something like that, store the rainwater harvesting, and that is in terms of the water part. Waste, you cannot just like that throw the waste on it. You need to do it composting and then make it a proper way so that it can be disposed of. Next is your net zero energy. Energy is one which is playing a big role in it. We have started doing a lot of data centers. Data centers are all you know, right? That is the future buildings or the energy efficient buildings. You all know every day morning we are using the mobile and thousands of good morning, good afternoon. So the net is going to get clogged, right? So much of data need to be stored and something like that. So data centers are the one where, for example, Microsoft, Amazon, all the big tech giants, commercial people, they need the data. So data centers are coming. What is the efficiency of the data centers? They have to be the most energy efficient. So as a civil engineer or architect, what they do is first itself you start doing the passive design. You keep, I think sir was mentioning about Autodesk product, what is that? The latest one? Pharma. So using the pharma, what you can do, the building itself can be oriented in such a way so that you get the least heat inside the building. Orientation of the path analysis you can do. How much light you want to let in, that can be taken care. So passive design you do it. Then comes the active part. How much of lighting I need to do it. How much of daylight I am allowing. How much of glare analysis I am doing. Then what is the type of glasses, whether I am going for a double glazed unit or today the facade technology has gone like anything. So you can decide what is the amount of heat you want to allow, how much amount of light you want to allow, how much you want to reflect it back. Thereby your air conditioning you are controlling. Air conditioning, again, once you come, there are chillers are there, right? They're all, we have got VFDs and something like that. It's all kind of real time, in the sense that it's not that air conditioning you have to run all the time. For example, this auditorium, we may not need this much light. This can be with sensors. So only when the presence of the people felt, it can be switched on and off. The multiple fans can be there, they can only operate. So the VFDs and the energy management system is the biggest thing. The sizing of the DG, sizing of the transformer. Today we have got all the technology where the energy efficient items are all there. You all purchase a mobile, right? Whenever you do it, what they say is least fast charging, quick battery life is long. Lot of research is going on the battery to save the kind of energy and stuff like this. So finally, if you see, we are all moving towards the saving of energy. Either it can be in water, waste, energy. Some of all this translates into the carbon. So fantastic future is there. We are moving from IGBC leads to green building, Griha certification. Now we are moving towards the net zero. Just to inform you, in our own campus, we have a TC4 building, Technology Center 4 building. That is the first net zero certified building in entire India. So we all work already. We got the awards and I think in other previous function. I thought I'll just share it because your question was more focused on the sustainability part and I think. And then you need to monitor. It's not only you do it in the design, you need to demonstrate, you need to do the measurements. That is where all that other IoTs, BIM and I think can come into picture. Right? Thank you.
Thank you, sir.
How are the emerging materials like self-filling concrete and transparent wood will changing the landscape of civil engineering?
One, with SCRC, a lot of research is going on. We are in touch with them and some of the products we are basically a construction company, right? In the sense we are corporates, MNCs, we want to build, make money. That is the part of it. But we need a lot of research to be done. We have our R&D lab where we are doing the high performance concrete, we are doing in-house. We are trying, we've reached up to 150 Newton per square, we have already reached. But the textile part of it, the self-healing concrete and other thing, that is not really our cup of tea, but probably that only the institutes, you need to, the academia, you need to spend time and then do the development. It need to come into, first you try, some of them we are trying in a small scale thing. For example, you can try for some precast cover slabs, you can try for the drains, you can use it where the least of this thing is so that your risk is not there. You spend some money, you do a testing, you validate that, then it can be taken into a larger scale. But of course, they are all going to be the future requirements because today the time is short, we are looking for early stepping. The moment because we need to have a larger cycle time. Whenever we have to do a building of 10 stories, 12 stories, 13 stories, we want to finish the construction in 6 months time. Which means every floor has to be done in 10-day cycle. Right? You understand that? 10-day cycle, every 10 days I need to pour the concrete should attain the strength, I have to remove the form and then I should take the form up to the next stage. All that thing, our conventional concrete can get into some kind of a damage. In the sense we don't know really, sometimes it all depends on the right quality of work, right mix and other things. So again, you know, the project cycle time is 18 months. You have definitely 2 monsoons will be there, 1 summer will be there, 1 winter will be there. Of course, Chennai you have only hotter. But we do projects everywhere. We do at northeast and other places where winter plays a major role. Even in Delhi, concreting, we have to do a very restricted time because of the extreme weather. We have 4 seasons there. So maybe yes, as you say, the self-healing concrete can be a solution to those type of situations where it can heal itself and then give us the kind of a strength where the cracks and I think probably we need not have to worry. It has got a future. Maybe I can give the reference of CRC. From my opinion, they can provide you more insights to that.
Thank you, sir.
Thank you.
Good afternoon, sir. Myself, Pambash Nivasan, and second year undergraduate student. So, I would like to ask you is what are the advancements in 3D printing technology in civil engineering that you think will enhance its usage in the future?
That you can discuss in person also. Sir have already explained in detail.
How to see? It is not all the projects are in different places. Maybe within India, with abroad, where it does. So now people want to sit in office and monitor everything, correct? People who don't want to go to site because very difficult, extreme health concern may be there, it may be winter or raining or summer, whatever it is. So under now most of the important always given to HSE in quality is topmost priority for everyone because that is the topmost one. How to control unsafe measures from site? There may be lot of, because no, L&T everywhere involved in EPC companies, we are all EPC companies. Work has been done at site, construction is doing at site. How to control the safety at site? Whether somebody is violating the safety norms. HSE is the most priority. So what we are doing in our projects, we are also making use of AI and drones. It will monitor all the places, entire project they will monitor. Suppose it, and also from office we can see at every plant, every location, every unit, we have a camera. If anything is going wrong, somebody is violating, suppose there is a construction going on and height, there will be some minimum distance required. No one will cross the particular line. If somebody is crossing the line, immediately the warning will come to head office. From fitting head office, we can monitor somebody is violating the safety norms. Then immediately we can call the site manager, we can tell somebody is crossing the line. It's unsafe measures. So these drones and AI, it is not only, even from offices, we can control everything at site. Somebody is, okay, the concrete is higher levels. Everything has been done, correct or not. We can monitor from office also. Through AI technology and drones. Drones has been now effectively used in all the construction sites to monitor daily progresses and also for the, especially in Technip now, we are using this drone technology for HSE and safety measures. All these things. Maybe this also maybe everyone is using this. Drone technology now has become very familiar and is very effective. From office now we can control everything at site also.
Just to add on your point, today if you see the Times of India news, our Greater Chennai Corporation of Tamil Nadu has given a work order to some private company to do a drone survey of all the roads. To give a live example, it's about 400 kilometers, 25 crores budget and all that. The expectation is the drone will do the complete survey and map the entire road, say that what is the width available, levels available, what are the encroachments, right? All this can be captured into a drone survey and this data will be useful. They can compare with the old existing records, find out is there any violations, deviations, how much amount of work, the quantification of the work and something like that, which patch need to be repaired. All that can be done. It's one example. Also, when we do a big projects, nowadays, city you don't get a space to build it. So whenever a big project comes in, we are getting into outskirts of the area. Again, I'm telling about a large mega kind of a project. For example, I have to do an airport. We have to do a Delhi airport. There it's about 5,400 acres of land. As I told you, we need to finish the project in 36 months and something like that. So we cannot be employing the so-called theodolite and tachymeters and I think to do the survey. So there the drone survey comes in very handy. You do the survey within 2 days. Entire thing is IoT things and something like that. Entire data can be exploded, put into this, get into a Revit model, 3D geometric model you can do. Using that you can do a lot of optimization, stuff like that is another aspect. Third aspect is we talked about the digital twins, right? So if I have to do it, already suppose this building probably must have built about 10, 12 years, 15 years before, you may not have the data as of today. But if you want to convert this into a digital twin, the best thing is that you get the drone, get the survey on spot, convert this entire data of conversion into the required thing in maybe a day or 2 or 3 days time. It does the survey, extracts all the information, builds the model and then gives over it. So that is one aspect. We also have the geospatial structures division in our L&T where the complete mapping of the profile, the ground based on Google Earth and something like that, we have the data. So tomorrow if I have to quote anything, I know up to a level of about 15 centimeter level. 15 centimeter for civil engineering is very big variation, but even then we can do a large scale data, we can have it. All the geotechnical informations, whatever we do, we all have got it in the geospatial information. So all these informations are all available. So it is multi-use. That is another field the civil engineers can explore.
I think that has a lot of depth. I think Sir has explained. I would like to give a kind of a few prospects, possibly outside India, what's happening here, because we have little experience over there. During construction, monitoring, I think definitely this particular thing, LIDAR scans and the drone surveys, the data what we get, what is called is one particular thing I want to coin here is orthomosaic. I think please Google that. Yeah, orthomosaic models. Yeah, what happens is, as Sir said, it's a kind of a remote locations or maybe within the site, maybe a kind of a reporting to the kind of a management in order to see that weekly reports. Yeah, have to go. So what we get a data is we get a the LIDAR the drone survey, and within 24 hours we turn back this particular model. Yeah, we have applications, plenty of applications are available. We'll just import that, and it gives a kind of exactly the image what is constructed on site. Yeah, it is a lightweight model. It's called orthomosaic models. Yeah, just to add on to it. Okay, that is something which is quite prominently we do on a during construction. I think we have a lot of applications, and there are other applications you can also available. The Bentley applications, open space, Chintu. These applications are plenty available where you can see a kind of a real status of the construction site. It's all IoT, cameras all fixed. That's what we say is a kind of a, we are in a global village. Wherever the construction site is available, you can see a real status of the construction sitting in Chennai or any location on the planet. Yeah. One another particular thing, a kind of a big obligation as a, for DNB contracts like L&T to add on to it is contractor have to submit the as-built data to the owner. As-built means what is constructed need to be submitted to the owner, because for any kind of a future expansions, rehabilitations, retrofittings, this data would be available. So what happens is the design data, when it is coming on to the reality, there are little deviations. I don't say the bigger deviations, but little deviations may be there in terms of a usage, in terms of erection, in terms of a survey, all those things, whatever the precision we talk, there will be little deviations. Those little deviations need to be done. I think during commissioning, it is captured in a kind of a red line markups manually, or maybe you can do a laser scan. I think now iPhone also can do a kind of a laser scan, yeah, laser scan, drone survey. So we get a kind of all these RCP, FLX formats. We can bring it into a kind of a platforms. Plenty of platforms are available. Autodesk has got, Bentley has got. You can reverse engineering that and superimpose with your design model. Identify a kind of a create a delta analysis where the deviations are there. Oh, column is moved by 2 mm. Yeah, that's a deviation. So you need to capture that and submit back to a kind of a owner. I think this is one another way the kind of a drone point load data or maybe leader scans will be utilized. Thank you.
Final year civil engineering. So what my query is, as we are moving towards sustainability, we the students are making a lot of projects on sustainable things. So for example, let me take my own final year project, which is a lightweight aggregate, which is manufactured using recyclable products. So what is the possibility of bringing these products into the industry?
What type of material you used to make our lightweight aggregate?
It is GGBS and copper slags. As we are doing sustainable projects, could we get it into the industry? Is there any possibility of making it in real world?
Good question. Actually, this is we can't directly use any material if you are discovering something or you finding out by testing other things. You need to do some testing to the CRC or IIT. Then it is proven that it is everything is fit. It is past tensile strength, compression strength. There are so many parameters are there to be cleared. Then if it is certified that material is good, then they tested in a test pad, something like that. But what is the GGBS are already under checking already the GGBS. Well, sustainable means you should reduce, as I said earlier, you should reduce the carbon dioxide content of the product. Any product, if you produce cement, cement is a lot of, concrete is the highest consumption of the mankind next to food. We use consumption of concrete, the entire world is second highest consumption of material is concrete. So in concrete, cement is major component. Cement consumes lot of heat energy. So if you use instead of normal Portland cement, if you use Portland porcelainic cement, you are reducing some carbon dioxide. Suppose 50 kg, it's come to 30 kg, something like that. What material you produce is good. Carbon, all waste material, whatever recycling, it is good.
So we are not using cement. Only the recycling waste is binded with the alkali activities such as sodium silicate and all. And what we do is we have tested it with IS standards and we have compared it with conventional aggregate. We have poured geopolymer concrete.
Manufacturing product is aggregate.
Yeah,
aggregate.
Aggregate. And we have casted concretes using those aggregates, and we have tested it in concrete too.
Yes.
And we have passed all the IS standards.
Okay.
So what is the possibility
You
of
did
building
compression
this?
strength, right? Cylindrical, cubical compression.
Compression and tensile.
That's good. Is any next go to IIT, ICS, you can check it.
Okay.
Next you can use definitely. See, olden days we are afraid to use that M sand, M sand. When you offer, people are not afraid. Now the people no other option to buy. They have to use it in sand. Nowadays I didn't ever see this Balar Manala Kadaka Martin. Bala Rupa this is a Patara Kudrana. Used by the people by afraid now building is standing with M sand. M sand is a waste product from the quarries. Now you know the quarries just that people are using because already tested in Dubai, Middle East, they're using it. So people will adapt later. Initially they won't adapt initially. If you are telling that this aggregate is good, it will withstand the slab, people will not accept it initially. You can construct on your own if you are confident that you can construct small pump or something like that, a security shed. It will pass, definitely it will pass. Then you can slowly incorporate it. There are so many testing procedures are there. But you can patent it, that you can do it. Nowadays, in the olden days, patenting is very difficult for us. Now, through Madam, you can apply for patent to Indian government. You can get the patent certificate, put it here now. Then it's good. That is good. You can record it. You are the authority for that product.
Thank you, sir.
Panelist for giving a high insight. Even I had few queries which I could not able to ask because of timeline. If anyone wants to ask any questions, since
so many questions they will ask. They have lot of questions. I have restricted. They have lot of queries. We will share your mail IDs so that they can ask.
Yes, you can share the mail IDs. Yeah.
Because of the time constraint.
Thank you, everyone. Thanks for your time. Yeah, thanks, ma'am.
We appreciate the time and effort taken by panelists to participate in this. We would also like to thank our students for their active participation and thoughtful questions during the Q&A session. Today we explored advancement in civil engineering, including 3D printing technology, modular structure, softwares like Tekla, STAD, and Primavera, fundamentals and insights of structure. We discussed the importance of sustainability, innovation, and collaboration in shaping the future of civil engineering.
As we have reached the end of our panel discussion, a heartfelt thank you to our panelists for sharing their valuable insights and experiences. Your contributions have provided us with a deeper understanding of the field. Thank you so much, sir. And also on behalf of the department, I thank the college for entrusting us with the responsibility of hosting this panel discussion and for their guidance and support throughout the organization process. A big thank you to our enthusiastic audience for your participation and engagement. Your curiosity and interest make decisions like these meaningful. We hope this discussion has inspired you to explore new career paths, upskill, and contribute to the field of civil engineering. Stay curious, keep innovating, and seize the opportunities that come your way. As you continue on your journey, remember that civil engineering is not just about building structure, it's about creating sustainable, resilient, and thriving communities. I request all the staff members to come forward for the photo.